Okay, there are a few things I want to cover with you guys before we start going over our creative projects. The first thing we need to know how to do is build our Unity environment into an executable, or an app if you're on macOS. There are actually a few advantages to this. The built executable will run faster than it does in the editor because there's a lot less overhead. So let's go up to File, Build Profiles. Let's click Open Scene List. If you have any other scenes here, you can click Add Open Scenes, or you can right-click to remove them. By default, whichever scene is listed first here is what is going to launch first when you open the executable. We want to make sure that this is our Unity ML Agents environment and not a menu or anything like that. Okay, so let's select our platform. Let's click Build. I've already created a build folder outside of our assets. This will build pretty quickly because I've already built to this folder, but the first time you build, it's going to take quite a while. It might take up to 20 minutes. Okay, so we have our executable. Let's go ahead and launch it. There is no trainer running right now, which means it will default into heuristic mode, but we can test it out. So space will lift us up, control will lower us down. We can use WASD to fly around left and right, and the arrow keys to rotate. Let's check that we get the reward we're expecting. By default, our reward will be constantly decreasing, and that encourages the agent to actually solve the task instead of just sitting around. So we give a little bit of a negative reward just to encourage solving the task and finding a positive reward elsewhere. We see that there is an immediate positive reward for landing on the pad, and then for every second thereafter, increasingly positive reward. There is a little bit of penalty added for if the drone is applying negative thrust while it's already grounded. This would bend the legs, and so we're essentially building this into our reward landscape. The rationale is that it has a distance sensor and it should be able to know when it's close to the ground and when it might receive this penalty. So go ahead and test this out, try it yourself, make sure that it works in your environment. Make sure that your agent is getting rewarded for the things you think it should be, and penalized for the things you think it should not. Pay attention to where you actually saved this build. On Windows, we can just right-click and select Copy as Path. Mac, you can do something very similar down at the bottom. We're going to use this inside of our trainer config and plug it in. You'll notice I've already done this, but you can just paste it into your environment settings. By default, I had this commented out. Remove the comment, paste it in. If you're on Windows, notice that when you paste it will use the backslash instead of the forward slash, and this is actually an escape character which a lot of programming languages don't like. So we'll just go ahead and replace some of those backslashes with forward slashes. Now when we actually go to run ML Agents, notice that I'm still in the runs folder. ML Agents Learn. This will specify the executable, and so we don't even have to hit play in Unity. And just like that, our environment is automatically launched. It is a little small, we can drag on the corners to increase the size. If you can't drag on the corners, I'll show you how we can fix that. On some operating systems like Windows, you can just hit Alt-Enter to go into full screen, but let's look at how to change that. Let's go back to our project, go up to Edit, Project Settings. Now inside the Player tab, scroll down and enable Run in Background, Resizable Window, Visible in Background, and Allow Full Screen Switch. You'll notice that there are these default height and width values. ML Agents is going to enforce a smaller screen size, and the reason for that is because it actually helps not to render a full screen. Just as an optimization trick, it usually runs in a smaller window. Okay, so far we've looked at how and why to build an environment to an executable. We looked at how to set the environment path, and there is one other advantage we should mention about having a built executable. We can actually automatically parallelize our runtime. So as we're training, it will automatically launch multiple executables. To take advantage of this, we just need to set our number of environments variable to anything above 1. So if we scroll up, we'll see a visual encode type simple. This indicates that this is a 2-layer convolutional neural network, a CNN. We have a few other options here. We could type nature CNN, which is a somewhat larger CNN. We can also type ResNet, which is a yet larger network. For the most part, we're okay using simple, a simple 2-layer convolutional neural network. We use the CNN, of course, to extract visual features from our environment. If you don't have a visual source in your environment, like you're not using a camera component, this line won't have any impact, but it won't be used. Raycasts, for example, don't use a visual encoder. They don't use CNNs, they're just fully connected. So we actually introduced a continuous action into our drone. As we know, our drone can move left, right, up, and down. But we also have this thrust. We can see that in the top right, visualized as a vertical bar. We haven't talked a whole lot about using continuous actions, but this is a great case for using it. In every other example, the motion or the action that we did was some type of discrete value. It was either a category or a button press. Here we actually have a value that the AI can choose between -1 and +1, and any value in between. Implementing a continuous action is actually quite simple. If we go into our Unity environment and select our drone, let's go to the behavior parameters. Let's just set our continuous actions to 1. We have 1 continuous action. And then the rest of the discrete branches are left as they are. It wouldn't be impossible to use continuous actions along each of your actions. For instance, we actually have a continuous drone in this environment, which I'm not going to go over, but feel free to enable it and take a look at it. It only uses 4 continuous actions, 4 different rotors with different thrust values to keep it level. Next, we need to look at the vector observation space size. Before, we had always set this to 0 because we had always been relying on some type of sensor, like a Raycast Perception 3D. This will automatically set up that vector observation space for us. But if we want to include optional custom information to the network, we will need to configure this. So for example, our drone has a raycast which points down to the ground and reports the altitude. That is a single float value which contributes 1 to our vector space size. We actually have 3 others that will be contributing as well. Here in collect observations, this is a default method coming from Unity ML agents. It's being run automatically just in the same way that start and onAction received and heuristic are. Collect observation gets called every time the agent collects an observation, and then it's fed into the network. So if there's some variable that you think is necessary for the agent to solve the task, you probably want to add it here, and then account for it in your behavior parameters as an extra observation. So in this case, we have the distance to the ground as our first observation. We are also allowing the agent to observe its linear velocity in the x, y, and z components. So keep in mind that we are adding an observation here, which is actually a vector 3, which means this vector 3 contributes 3 observations. Unity lets you add your own observations quite flexibly. If you added a Boolean value, it would automatically convert them to 0 and 1. So our first observation is our altitude. Our second, third, and fourth are our velocities in x, y, and z, meaning in Unity we need to match this number. In total we have 4, so in our behavior parameters we need to make sure that we have 4 set here. This is something that Unity won't be able to do for us automatically. That is one of the nice things about using some of the built-in sensors, is that these sensors will automatically add their values into the observation space. We don't have to calculate it by hand. Okay, so we've looked at how to set up our visual encoder, how to visualize the network, how to add a continuous action. Now we want to see how we actually use that continuous action. So how do we actually use it? Just like before on our onAction received, we have this actions argument that comes in. We assign some of our actions to our discrete actions, but we can also assign something to our continuous actions. So for example, continuous action 0, this is our first continuous action. And then we can use that value however we would like. Okay, similarly, we need to understand how this affects our heuristic function. You can see that we have 2 different types of actions here. We have our discrete actions and now our continuous action. Only one of them. So since our keyboard doesn't have a scroll wheel and it's not a joystick, we have to map some action to a value on that continuous range. We can just set the space to be +1 and control to be -1. This is about the best that we can do, but at least it lets us test the agent. The AI itself will be able to use every value between -1 and +1. The next thing we should focus on is how to demonstrate that we are continually training our agent. So of course, when we hit play, the episode counter will restart at 0. But what we can do is open up the trainer terminal. A lot of you have reasonably said I've been training this for a little while, but it's actually at, episode 50 when it only shows as 0. What we should do is then show the terminal. This actually keeps track of the steps, and this is continued between runs, even if you use resume. And also, our episodes could be kind of arbitrary, because when the drone hits the ground, it ends the episode, even if it was just a few steps. So not even every episode is the same length. 500 episodes might seem like a lot, but it might be churning through episodes as it starts to learn how to actually act in the environment. So when we last looked at this environment, we had a slightly different environment, and the agent probably wasn't going to actually train from that point, and that's because we actually gave it a pretty difficult task. If we have a really difficult reward landscape, the odds that it's just randomly going to accomplish it are pretty low. So what we can do is essentially make the task easier, and then gradually make the task harder. Kind of like being on a curriculum, and that's exactly what we call it. So this is called curriculum learning. We start with a simple task, and the more that it completes this easy task, the more that we move on to more challenging tasks. So we set our agents up for success by letting them build skills and proficiency in simpler tasks before moving them on to more challenging tasks like landing on the platform. So we want to start easy and then gradually increase the complexity. In many ways, this is exactly like a course. This would be a really difficult project if I just asked everybody to randomly, on the first day of class, try to execute this project. So we created smaller benchmarks, smaller milestones, lessons, feedback, reward throughout that entire process. And by the end, you've scaffolded their learning to the point where they can do it by themselves. But of course, you have to put in the episodes. So what we've done is we've built a small little drone manager. This sets up a curriculum with a few options. One of them is the minimum pad distance, maximum pad distance, and keeping it close ensures that the drone can actually see the target pretty much near the start. That way it can begin to associate that shape and color with a reward. And what we do is if it can land on the platform 100 times, then we graduate it, we move it on to a more challenging environment. Just a little bit more challenging. One of the other things we can do is decrease the number of steps at the start and then gradually increase them. If we have really high number of steps at the start, there's a good chance it's going to spend many of those steps not even looking at anything that's potentially rewarding. So we want to stay focused on the task and then start learning. And then once we've increased the distance from the start, we'll also increase the number of steps that it can take. It might need that because it could be that the platform has moved quite far away. It might take more time to find it, and it might take time to reach it. Okay, this is about everything for now. I want you to go through this project, take a look, specifically look at some of the things I've brought up in this video. We have curriculum learning, we have continuous actions, we have a visual sensor, a visual encoder. We're using a build instead to train. We've looked at how to set up additional observations and what it means for our vector observation size, and how to calculate that. If you have any other questions, please feel free to ask and let me know.